All right, these are topic 8.3 notes. We do have a quiz coming up tomorrow. We're going to talk about 30, 60, 90 triangles today. So here we go. All right, first one here, we're asked to follow these steps. We're just going to kind of prove, not really prove, that freaks y'all out, I know. We're going to talk about why we can say the side lengths are what they are with these 30, 60, 90 triangles. Okay, so we're going to talk through that. We're going to kind of do a little bit of discovery activity to start. So if I'm drawing the height of the triangle, first things first though, what type of triangle am I working with right now? Equilateral. Why do I know it's equilateral? All sides are congruent. Okay, so what does that tell me about all three of those angles? They are all 60 degrees. Okay, so if I'm thinking about this, I've got 60-degree angles all the way around. Now, if I draw that height, which is what it's asking us to do in number 1, okay, what does that mean this top angle is? That's going to be 30. Okay, and then this is obviously going to be a 90-degree angle. Okay, so we've got the 30, 60, 90 triangle. So I'm going to kind of outline that here. We've got the 30, 60, 90. Now, right now what we're asked to do in number 2 is tell what was formed. Obviously, what was formed here, guys? 2 right triangles, more specifically 2 what kind of right triangles? 2 30, 60, 90 triangles. Okay. Now we're asked on number 3 to label the short side A. I'm going to change that to X because you're going to more likely see X than you will see A. Okay, so label the short side X. So that would be this bottom part right here. So let me ask you a question. If that's X, what is this full side length going to be? 2X. So do you agree that each one of these is going to be 2X? With me there? Okay, so again, focusing back on our 30, 60, 90 triangle. If I've got one side is X and one side is 2X, how could I possibly find that third side length? Think back to what we did on the very first day of notes. Pythagorean Theorem. We've got 2 side lengths. Can't we easily find the third side length? Okay, so let's do that. So we can do a squared plus b squared equals c squared, where our a value is just going to be x. Okay, b value, we don't know that yet, right? That's actually what we're trying to find, so we're going to leave that alone and say b squared. What do I know c is? 2x, so we've got 2x squared. Now what is 2x squared going to be? 4x squared, very good. Do you guys see what to do next? What? Good, subtract that x squared and move it over. We've got those like terms that we can combine. So I'm coming up here, we've got b squared is equal to what? Good, we did 4x squared minus x squared and got 3x squared. Suggestions for our next step? Perfect, we've got to get that b by itself, so we're going to take the square root of both sides. So we get b is equal to, now see if you can follow with me here, just like I did yesterday on the notes. Do you agree that I can say that this is square root of 3 times the square root of x squared? With me so far? Okay, now square root of 3, I can do factor tree with it, but I'm just going to get square root of 3, right? Because 3 is just a prime number. So we're going to leave that alone. But what is the square root of x squared? X. So we've got b is equal to x square root of 3. Now this holds true with all 30, 60, 90 triangles. The short side will always be x, or the side across from the 30-degree angle will always be x. The side across from the 60-degree angle will always be x square root of 3, and the side across from the 90-degree angle will always be 2x. Okay, so let's label this picture down here. Across from the 30 is going to be x, across from the 60 is x square root of 3, and across from the 90 is 2x. So there are 2 types of special triangles here, special right triangles. We talked about 45, 45, 90 triangles yesterday, where we labeled the 2 legs x's, and the hypotenuse was x squared root of 2. And then today we're talking about the 30, 60, 90 triangles. You will need to know both of those triangles. Okay? Questions so far? Okay. Let's work some examples. All right, on number 1. We're asked to find several different things. The first thing I always want to do when I'm starting these, though, is I want to label the picture. Okay, so if I'm looking at example 1, let's label the picture. Where should our x go? On the bottom, very good. Where should our x square root of 3 go? On the left side, good. And where should our 2x go? On the hypotenuse. Perfect. Now, which one of those side lengths do I know? I know the hypotenuse, or the 2x, so I know 2x has to equal 14. So what does x have to be? 7, which told us the length for MN. Okay? Now, to find the length of LM, okay, LM is just given by x square root of 3, but what do I know x is? So we can take 7 and substitute it in, and we get LM's length to be 7 square root of 3. All right, let's look at number 2. It's a little bit harder. Help me label first. Where should the x go? On the left side. Okay, what should go on the bottom? X squared root of 3. What should go on our hypotenuse? 2x. And obviously we know what x is equal to. X is equal to 2 square root of 5. So if I'm finding Ln, I want to do 2 times x, or 2 times 2 square root of 5. What does that give me for Ln? Good, 4 square root of 5. If I'm finding Lm, that's given by x square root of 3, but again, I know what x is. It is 2 square root of 5, and then we've got the square root of 3. So what does that give me? Good. Remember that you can multiply two values that are both under square roots here. So we can say 5 times 3 and get 2 square root of 15. Excellent. Okay, number 3. Help me label. What's the left side? Good. What's the bottom? And what's the hypotenuse? Good. And what do we know? We know x square root of 3 is equal to the 8 right here. Good. So what should I do to solve this one? Good. We've got to get rid of everything with the x. So we divide by the square root of 3. What next? Multiply by the square root of 3. Divide by the square root of 3, then multiply by the square root of 3. Okay. Similar process to what we did yesterday, right? Just a different number. Yesterday it was square root of 2. Today it's square root of 3. Nothing different other than that. So what do we have left? Looking at the top, what's left on the top? 8 times the square root of 3 gives us 8 square root of 3. And what's left on the bottom? Just 3, right? Square root of 3 times square root of 3 is just going to be 3. So what did that tell us the side length of? Mn, right? Because we knew Mn was just x, and we found x to be 8 square root of 3 over 3. So we can go ahead and write that in. Now how do I find Ln's length? Good. So we've got Ln is equal to 2 times x, so 2 times 8 square root of 3 over 3. Now be careful here. If it helps you, think about this as being like 2 over 1. Okay? So what would that be if I multiplied then? Good. 2 times 8 gives me the 16 square root of 3 over 3. Okay? A little bit worried about people giving me 6 instead of 3 in the denominator. Be real careful to realize that that 2 is only multiplied on the top. Okay? Think about it as being over 1 if that will help you not make that mistake. Okay? All right, example 4. Where should the x go? Good, that should be on Mn. Okay, what should be on NL? 2x. They're trying to trick you by putting a square root of 3 on that number. That is the hypotenuse, which should be labeled as 2x. So obviously ML's length should be x square root of 3. Good. So we know that 2x is equal to 4 square root of 3. So we just divide by the 2 and we get x to be what? Good, 2 square root of 3, which told us which side length? Mn, very good. So the only other side length I'm asked to find here is ML, which is given by x square root of 3, perfect. But what do I know x is? 2 square root of 3, so we've got x square root of 3, so 2 square root of 3, square root of 3. So what does that give me? 2 times what? 2 times 3, because square root of 3 times square root of 3 is just 3. So what's 2 times 3? 6. Questions so far? Okay, you see the similarities to yesterday? Okay, pretty close. All right, let's look at example 5. What should I do first on example 5? Perfect. Draw that triangle. More specifically, what am I told about our triangle? It's equilateral. Very good. So you can kind of think back to the first problem we worked today. If it's equilateral, what does that tell us about all the angles? They're all 60. So what type of right triangle am I working with? A 30, 60, 90. Very good. Now, when it asks us to find the length of the altitude, what is the altitude? That is the height. Do you recognize that with an equilateral triangle that the altitude is going to be representing the height? Okay, so this is the height of our triangle. And what do we know about the triangle? Good, each of the sides is 11, right? Now what does that mean the bottom has to be? 5.5, do we agree with that? And that is, I heard someone say just a second ago, that is our x value. Good. What is the across from the 90 going to be? That's going to be our 2x. And across from the 60-degree angle? X squared root of 3. And that's actually what we're trying to find, right? Because that's our altitude. So the altitude is given by x square root of 3. But what do I know x is? Because we just discovered that. That's going to be 5.5. So our altitude is just going to be 5.5 square root of 3. Does that make sense? With the picture, that is very, very easy, hopefully, because it's just like the other types of problems we've worked, so make sure you draw out the picture, okay? All right, example 6. Now, on this one, I say specifically to use similar triangles to find FY and YL. So I'm going to draw another triangle. And just like we did yesterday, obviously this is going to be a 30, 60, 90. Just like we did yesterday, I want to say that x is 1. Okay, so across from the 30 is supposed to be where my x goes, so I'm just going to label that as 1. Okay, so if x is just 1, what is going to be on the right side of my triangle? Just square root of 3, because this would be x square root of 3, so 1 square root of 3 would just be square root of 3. You agree with that? And then across from the 90-degree angle, that's going to be 2 times x, or 2 times 1, which is 2. Okay. So now the first thing that I'm asked to find here is Fy. Now, just to keep from making this confusing, I'm going to call Fy, I'm going to label that with a Z. Okay. Just making up a letter there to help us know which side we're talking about. When I say Z, you'll know what I'm looking at. Okay. Now, obviously, that's what I'm trying to find. So I want to set up my first ratio with that Z. So what's corresponding to Z on my other triangle? The 2. So I did Z over 2. You could have done 2 over Z, whatever floats your boat. Okay. Now, what's another good side to use? Obviously, the only other side I have here would be great choice. So 6, and what's corresponding to 6? Square root of 3. So we do 6 over the square root of 3. Then we just cross multiply, and we've got z square root of 3 equals 12. And what should I do to solve now? Divide by the square root of 3. Then what? Multiply by the square root of 3. So what do we have left on top here? Good, 12 square root of 3. And what's going to be on the bottom? Square root of 3 times square root of 3 is just 3. And that actually reduces to what? 4 square root of 3. Perfect. Which told us the length of Fy. Okay. Now let's switch gears here because we're also asked to find YL. So let's call YL W. I'm just making up letters. Okay. So obviously that's what I'm trying to find here. So what's going to be corresponding with the W? That's going to be the 1. So W over 1. And then I would use the 6 and the square root of 3 again. Cross multiply, and you get W square root of 3 is equal to 6. And then what would you do? Divide by the square root of 3, then multiply by the square root of 3. Perfect. So what's left on top? 6 square root of 3, and what's left on the bottom? 3. So if I reduce that, what do I get W to be? which gives me the length of YL. All right, last example, number 7. All right, on number 7, hopefully you're recognizing that there's actually a couple of triangles here. What are you seeing? We've got a 45, 45, 90 that's over there on the left, and then on the right we've got the 30, 60, 90. Okay, so we've got to kind of remember what we talked about yesterday as well as what we've learned today. All right, where do you want to start? It might be a good idea to start where there's actually a side length. So maybe over there on the left with the 45, 45, 90. Okay, just a thought. You know, you might want a side length there. All right, so help me label the 45, 45, 90. Good. Where the 8 is going to be our x square root of 2. Good. What are the other two side lengths going to be? Those are just going to be x. Good. Okay, so we know x square root of 2 has to be equal to 8, right? So to solve this, just like we've been doing, we're going to divide by the square root of 2, then multiply by the square root of 2. And what do I have left on top? We've got 8 square root of 2 over what's left on the bottom? 2. And we reduce that to get 4 square root of 2. And that tells us one of the answers here. We've got LU is 4 square root of 2. Okay, now I'm going to erase some of the work so that we don't make this too confusing looking, but we've got 4 square root of 2 here. So now let's focus on our other triangle. Okay, help me label that one. Where does the x go? Yeah, the x is over there with the 4 square root of 2. That makes it nice, right? What goes on the bottom of that red triangle I've outlined? X square root of 3. And then what goes on the hypotenuse of that triangle? 2x. Good. So we know x is equal to 4 square root of 2. So I can do 2 times x, or 2 times 4 square root of 2, to find our SG length, which is what? 8 square root of 2. Perfect. And then on the bottom, I know that side length is x square root of 3. So I can take what we know x to be, which is 4 square root of 2, and substitute that in. And what do you end up getting down there? 4 square root of 6. And that can't be reduced any, right? It would just factor to be 2 and 3, which are not a pair, right? So we can leave that alone. All right, that does complete topic 8.3 notes. You guys are more than welcome to come in for tutoring and get some questions answered if you have any. Hope you have a great day.